Hi to everyone. MEM School of Engineering, Department of Mechanical Engineering, online classes, subject code ME8791 Mechatronics, unit number 2. So myself Saravanan, Assistant Professor in Mechatronics Department. Course objective and outcomes, syllabus, textbooks and reference, unit 2. Till now in unit 2 we discussed the architecture of 8085, pin diagram and addressing modes of 8085. Today we are going to see about the instruction set of 8085. That means what we are going to do. Okay, that is instruction. The type of instruction we are going to see in this chapter. So last class we discussed with the addressing mode, that is direct addressing, register indirect, immediate addressing and implied addressing. So classification of instructions based on the functions. Okay, classification of instruction with based on the instruction functions. That is data transfer group, arithmetic group, logical group, branching group and machine control group. That is data transfer group means we are sending the data from one location to another location between register or between memory to register or register to memory or register to direct memory, like that. It is a data transfer group. Then arithmetic group, that is performing the operations, addition, subtraction, multiplication, division, like that we are going to see. Then logical operation, undo or XOR, like that. Branching operation means so jump, call, like that we are going to discuss. Then machine control. Machine control means reset, clock enable, halt, in and output, like that we are going to see in the machine control group. There are 5 groups, that is 5 instruction set available in the 8085 microprocessor. Let's see one by one. First, data transfer group. Okay, so data transfer group generally will be move, load of data, then store of data. So like that we can use the move, that is data transfer group. That is move operation, then load operation, store operation, then push and pop, like that. It will be a data transfer group. First we see the move, RD, RS, that is RD means destination register, RS means source register. So this instruction will copy the content of source register to destination register without modifying the content of source register. So they gave the example, let A is equal to 87, C is equal to 55. So instruction move C, A. So that means we have copied the data A to C. So A value will be 87. So after execution, C value will be 87. This is the concept. So this is an example for data transfer, because we are transferring the content of accumulator value will copy to the C. Data transfer group, that is move from memory to register. Okay, so that is memory to register. So there is the another example. So last one we have 2 register. Here we are using the memory and the register, but same move concept. So other like that. That is MVA also data transfer group. Next, load operations, that is LXI. LXI, that is load 16-bit value and wrote to the register pair. Okay, so that is 16-bit data will be loaded to the register pair. It is a immediate addressing mode. Then data transfer group. So bytes will be 3 byte, flag and none. So flag means flag affected flags. Okay, for this operation, after execution of the function, if any flags is affected, like that, it will be show. Okay, so this is the format. Addressing mode is immediate addressing mode. group data transfer group. Okay. So this instruction will load the specified register path with the 16-bit data specified in last 2 bytes of instruction. So byte 3 is moved into higher order register and byte 2 is moved into lower order register. So example is LXI B comma D500. So another one is load A address, that is 8-bit data load from the direct address. So that is they are giving LDA 7000 means content of 7000 will load into the accumulator. So here this instruction will load the accumulator. This instruction will load accumulator with the content of memory location whose address is given in the last 2 bytes of instruction. So content of the memory location remain unchanged. So let 9580 is equal to 28. So that is a 9580 memory location having 28 and accumulator value 55. So after execution of LDA 9580 means A value will load into the particular value will be loaded into the okay, that is content of 9580 828 will be loaded into the accumulator. This is the concept of LDA for getting the input. Okay, because most of the inputs given through the memory, so we need to access the memory. We need to get the memory to the accumulator. STA store accumulator content. Okay, so next is store accumulator content, that is STA. That means we are sending the data A value to the particular address location. So that is direct addressing mode, data transfer group, then 3 bytes, flags not affected. So let C050 is equal to 28, A value 66. After execution of store accumulator content 00C050, A value 66 will load to the C050 memory location. So this is the another example of data transfer. So like that we have LHLD, SHLD, LDAX, HDX, exchange. So like that we have different data transfer group instruction. In university exam they will ask particularly like that if explain data transfer group some instruction means you have to explain all the instructions in the data transfer group like that move any one of the example. Okay, move, load, store, LHLD, SHLD, then exchange. So like that we need to explain. In if they asking generally instruction set means you can write some of the 3 examples like that you can explain. Next arithmetic group. So first one is add. So add with the register. So here they are putting a register addressing mode, arithmetic group. So byte will be 1, flags on the all. That is, it will affect the all the flags because we are going to perform arithmetic operation. Okay, the content of register R is added to the content of accumulator. So the result is stored in accumulator. So that means all flags may be affected. So let C is equal to 27, A is equal to 15. Okay, for example, add C means we are adding the 27 and 15. Okay, output will be 3C. So let's see the changes in the flags. So here output will be positive value, so sign value will be 0. So because we are adding the unsigned value, so sign flag value will be 0. So there is no output 0, so output on the 0 varla, so 0 flag value will be 0. Then there is no auxiliary carry between D4 and D5, so auxiliary carry will be 0. Then output will be parity flag 1 because we have even number of ones, so parity flag will be 1. So Cy is equal to carry is equal to 0. There is no carry in the D7, so it will be 0.